So today is Wednesday, January 28th, and because we can't really miss two classes in a row right here at the very beginning of the semester, I'm going to go ahead and record going through the rest of our vocabulary terms and reviewing a little bit about Visual Studio and how it works. So okay, so first I went to the weekly lecture. So if you just kind of go to just our basic, D2L. Then in the weekly lectures folder in week one, I have everything split up. Well, week one is the only one that has course documents. All of the rest of the folders are going to be split up into our slides and handouts for class and then the homework. So you can kind of go through and find what you're looking for. Right now, I'm going to go through the vocabulary slides. So I'm coming into this first folder. And then these are the ones that we already went through. We went through chapter one slides with Slido on Friday. So then this is the remaining half of them here. So I'm going to go through this one, chapter one slides continued. So what is a program going to have? I mentioned reserved words on Friday. Reserved words are words that have special meaning. They are specific to your language. So, like, there's a different command for print in C++ compared to Python or Java or some other programming language. So, those reserved words are going to be the same for everybody. Everyone in the class is going to have int main. Everyone in the class is going to use cout. Those will be the same for all of us, and they will be the same in like every program that we write. But you will also create some things in your program yourself. You will create your own variables. You later in the class, you will create your own functions. And so some of these things are going to be programmer defined, meaning you, as the programmer, made them. And those are things that, as long as you follow the naming rules, those can be whatever you want. So those are all going to be a little bit different. Those will be different for each student, those will be different for each program. Operators are the same as they are in math. We can do mathematical operations, so we can have, add, subtract, multiply, divide, things like that. And then the punctuation and syntax rules, we can think about the program syntax kind of like grammar when you're writing in, like English or whatever language. You have all these rules about where do you put commas and periods and quotation marks and things like that. And we will have some syntax rules for our programs as well. And those will just take a little bit of time to learn. So this is a sample program, and we can kind of recognize some of it, right? We've seen this first line before. Include the library to have input output commands. So that command right there is why I'm allowed to have this cout, right? I'm allowed to say print out to the console this text here. Using namespace standard, we've seen that line before. That just tells us that we are kind of using the standard namespace for all of our different commands and variables. So I talked about that a little bit on Friday, but that just kind of says once we start bringing in, custom libraries or like programmer defined libraries we might have multiple different commands that have the same name but do different things because they could be from like different libraries that we've pulled in. Right now, we are not using anything but just standard template libraries. So we can just use the standard namespace for all of our commands and instructions. So that's just kind of our skeleton, right? And we know that int main tells the computer, this is where I want you to start. Okay, the main method is where it should begin when it tries to go through and read these instructions. This requires We haven't really seen making variables yet, but I'll talk about it more when I show you the Visual Studio example in just a little bit. And we will talk about making variables more next Monday when we're in class in person. So those words have special meaning. You cannot use them for anything other than their intended purpose. So, like, you can't make a variable and call it main, for example, because that would confuse the computer. When it sees the word main, it knows, oh, this is where I start, execution. You cannot make your own variable and try to call it a name that already has instructions associated with it. It is case sensitive. So if something is like everything in C++ is case sensitive. So if you have a command and you capitalized it, but it should be lowercase, the computer will not recognize it. It won't, like, it will see that as a completely different word. Okay. However, the variables that you use in your computer or your functions or different things where you create the name for them, those are going to be made up by the programmer. They are not like an inherent part of the language. So those can be things that you make yourself. And whenever you make something like a variable, for example, what that is going to be is a place in the computer's memory that you reserve to hold some piece of information. So let's say that I need to keep track of somebody's name. I could make a variable and tell the computer, this is where I want you to keep track of this person's name. Or let's say I ask the computer to do like a mathematical operation. I could say, go do this math, and then I want you to save the answer inside of this variable. So we say this is some place in memory reserved for this piece of information that I need you to keep up with. Okay. This is just an example of making a variable. So in this example, we have two pieces of information. Number one, the data type, and number two, the variable name. So they just chose to name their variable num1. There's nothing special about that. They could have named it Jim Bob. Like, you could name it whatever you want as long as you follow the naming rules. A type tells the computer what kind of information, right? What type of data can you store inside of this variable? What type of information can you save inside of this space? And that matters because it tells the computer what kinds of operations it is allowed to do with that information, right? If I'm going to save someone's address, like a mailing address where you live, the computer cannot do mathematical operations with that data, right? You don't say, what is 818 South Oak times 2, right? You don't say what is 818 South Oak divided by 4. Like, that is not an allowed operation on that data type. But if I want to save numbers to do calculations with, I need to tell the computer this is a numerical piece of data. You are allowed to go through and do these different operations. And there are different operations that are specific for, text. I could say something like, how long is this text? Or, does it contain this certain letter or whatever? So I need to tell the computer what type of data it has so that it knows what kinds of things it can do with that data. Also, the computer needs to know the data type so it knows the space. It needs to know, like I'm saying, go reserve me some space in memory to store this information. So the computer needs to know how much space do you need, right? Is this going to be a tiny little, like, 2-digit piece of information, right? Are you saving somebody's age, which will never be more than 3 digits, right? That's a very small piece of data. Or are you, calculating the distance between planets and the solar system? Those are going to be huge numbers, right? You need a lot more space reserved for you. So I mentioned on Friday that we as programmers always want to be efficient with our programs. We want our programs to be as small as possible so they will run quickly and they won't take up a bunch of space. Like the programs won't be big and huge if we don't need them to be. So we tell the computer, I need a enough space for a very small number. And then the computer doesn't reserve you some big, huge box when you only needed a tiny little piece of that. Mathematical operators that we can do are like add, subtract, multiply, divide. There are others that we'll learn about in week 3. And then this is the assignment operator. So in C++, and honestly, in most programming languages, the equal sign is not going to be the equal sign. Okay. The equal sign is going to be the assignment operator, and it's going to say, go solve whatever is over here on the right hand side. So, like here, it's just the number 12, and then store it at this place. I want you to take this information and I want you to put it in this location. Okay, so I want to take the number 12 and put it inside the variable num2. I want you to go add num1 and num2 together, and then I want you to take that result and put it in the variable called sum. We mentioned that most of our commands are going to end with a semicolon in C++. That semicolon means stop. It says, I have finished. This is an entire programming statement. I am done with what I needed you to do. This is the end of the line. So, the semicolon is kind of like a period at the end of a sentence. And one thing to note, if we were in class, I'd kind of do this on the board. I'd make like a little, kind of look like a little piece of paper, and think about like if you're writing sentences, like you're going to write an essay and you start typing and you have your sentence. Is it possible that you might have a sentence that goes do 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 period? Right? Is it possible that you could have a sentence that spans more than one line? Absolutely. Like, of course you could. This right here is an example of a sentence that goes on to 2 separate lines. So would you put a period right here because it's the end of the line, even though you have not finished the full entire sentence? No, of course not. So you don't have to have a semicolon at the end of every single line in your program. You have a semicolon at the end of the statement. So here is an example where they did several different things and it was kind of long and it ran over 2 lines. But see, you only have the semicolon when you're done. Most of the time, we will have a semicolon at the end of each line, just because most of our statements are going to be short. And so most of them will fit on one single line, especially in CS1. What I just said, it doesn't really matter that it's the end of a line. A semicolon goes at the end of a statement when you have like completed your thought. The person who made these slides really wanted to drive that in, didn't they? 3 slides to say that, but okay. All right, so I kind of already talked about variables. A variable is a place in your memory. So remember, RAM is your main memory. So a variable is some location in your memory that you have reserved to store some piece of data. The information that's inside of that can be overwritten. You can think about it kind of like a variable in math, right? Like we might say like x equals 3 plus 4. So, okay, you do 3 plus 4, you get a 7. X equals 7, right? X is a variable and it has some value associated with it. You have to create the variable before you can put information in it, before you can store something in it. How do you create the variable? This right here. You need to tell the computer the data type and the name. That's it. That's all you have to do to make one. Just go ahead and tell you so that this isn't confusing. These are two different examples of data types. Int might be kind of easy to guess, right? What's a, what does int kind of sound like? That could be like a piece of information. Int is short for integer. So that's going to work the same way that it does in math. It could be any positive or negative whole number. So no decimals or fractions or anything like that, just whole numbers only. Could go inside of num1. And then a double is going to be a number that can have a decimal. So for example, num2 could have like 8.21, but num1 could only have like a, -3, 14, 0, something like that. We talked about this. The steps for processing are you get input, you process the data, you have to get the output back out to like you need to send the result back out somehow, print it to the screen, save it somewhere, write it to a file. You need to do something with it. It doesn't do us any good for the computer to know the answer. We need to get the answer back out to the user somehow. Okay, and I think this is actually, yeah, this is the end, so that's good. So here we're going to talk about what are some of the possible different errors that you could get when you try to write your program. And we're going to kind of classify the errors into three different types. So a syntax error, remember that syntax is going to be kind of like our grammar. You forgot a semicolon. You don't have the parentheses after int main. You opened a curly brace, but you forgot to close it. Something like that, right? So if you have some sort of error in the way you wrote the code, it will not even compile. So if you remember, what is the compiler? The compiler is the thing that takes our code, our source code that we as programmers wrote. The compiler takes that source code and then translates it into machine code that the computer can understand, right? The computer understands binary and zeros and ones and things that's not how we go through and write our code. So the compiler translates for us. If there is some mistake in the way your code is written, then the compiler cannot translate it correctly, right? So it's going to stop and be like, I can't move forward because this is not valid code. So that's one possible mistake. Another one is your code might be written correctly, but you can ask it to do an invalid task. So a really common example of that would maybe be like you asked it to divide by 0. I could write that validly. I mean, I could write good, correct code that said, see out 3 divided by 0, semicolon, and it could all be written right and there could be nothing wrong with the code. But when the computer tries to actually do it, there is no way to divide by 0. That's, an impossible task. And so then the computer would crash out and it would say, that would be a runtime exception. I tried to execute what you gave me, but I couldn't. A semantic error is the worst kind of error to go through and debug and find because a semantic error says that your code works and it runs and it's not telling you that there is a mistake, but that you logically did something wrong. And so your result is incorrect, right? So, for example, you multiplied when you should have added. The code doesn't know that you should have added, right? It doesn't know what your intention is. So if the code is valid, if it's written correctly, if it runs correctly, it's going to go do exactly what you asked it to do and be like, "Yep, we're all good. Here's your answer." But the answer is completely wrong, right? So that would be a semantic mistake, and those are very hard to go through and check. So sometimes you want to look at the result that your code gave you and you want to like maybe just do like spot check, like just kind of one example or something and say, is this answer that it gave me reasonable? If you ask the computer to calculate an area and it gives you a negative number, well, that makes no sense at all, right? We can't have a negative area. So that would kind of be like I might need to go back and double check my code, make sure I didn't make a mistake in here somewhere. Okay. How can you try to go through and find a mistake? Go through by hand and kind of see, okay, step through it, what would happen here. There are like debuggers inside of our programming environment. Visual Studio has a debugger built into it. And so we can go through and like it will run it line by line and it will show you what is being saved inside of your variables at each step. Or you could put like print statements. You could run just like a little bitty bit and then be like print, okay, what what happened at this point? And then, oh, okay, we're good there. So let's move down. Let's run another part of the code, test that out. Okay, do another C out statement. What happened here? Oh, this time it's wrong. Well, then the mistake must be somewhere here in this second step, right? And you really don't need to know about that, but not all languages are compiled like C++ is. So, for example, Python does not go through and compile the whole entire file and then run it. Python is interpreted, so it takes one instruction at a time and tries to go like run that one instruction at a time instead of translating the whole entire file all at once. So that was all of our slides there to kind of wrap up our vocabulary. I'm going to go ahead and take a look at this vocab homework and talk about our quiz a little bit because we will have a quiz on Friday over vocabulary. And the way that quiz will look is the definitions will be exactly from the homework. Like I will pull them straight from the homework, right? It will say, part of the CPU that coordinates all the computer's operations. And you'll have a little word bank and you just write in the term. So it will look just like these. And we did the first page in class. So I'm going to go ahead and just skip down. Single binary digit is a bit. 8 bits is a byte. I do think these two can be easily confused for each other, so I would never give you both of them at the same time on a quiz or exam because I think they're very kind of like interchangeable. But volatile would be that it is erased when power is removed. That's just kind of the definition for what volatile is. Oh, no, 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 sorry. These are the two that I think are very interchangeable. Because this is like storage for instructions and data, and then this says where instructions and data are stored. So I feel like those are very similar. If you look in the slides, these do just kind of match the definitions in the slides. So this one is going to be RAM. So this one's main memory. And then this one is going to be the registers. So kind of the big difference there is your registers are there like inside your CPU and they're going to hold like one instruction at a time. And the computer has to actually move the data from memory into the registers to go through and actually execute like one command. And then it has to go get the next data that it needs for the next instruction and bring it up there and they get overwritten all the time. I'm pretty sure it's written that way. I may need to go back and double check the slides actually to make sure of that. Since human language, I want you to think about that like it's very high level, it's very like sophisticated, right? So it's kind of easier for us to go through and understand those high level languages. However, a low level language is kind of more rudimentary. So that's more like what the computer understands. So something like machine language or assembly, where you have to specify, take this piece of information and put it in this register. Take the data in this register and do this operation. Like it's very, very basic, right? And it takes a lot of instructions to do one simple task because you have to spell out every single part of how that actually happens under the hood. So I can't just say 3 plus 7. I would have to say, okay, we're going to load the 3 here. We're going to load the 7 here. We're going to perform this operation with these 2 pieces of data. Like it's going to be more low level, as in communicating directly with the hardware. Okay. Oh, yeah, which is like that whole first sentence there, huh? It's almost like I wrote these. Okay. Who is our translator? The compiler. Um, the translated machine language instructions, but that's going to be our object code. The programmer, of course, writes the source code because the program has to come from somewhere. You are the source, right? You are the one who wrote the instructions to begin with. And then it's going to translate that. So we'll get the object code, and then we have to use that linker to get the executable code. So the big difference between like object code and executable code is that an executable file is able to open and run on your device. So that linker has to go through and say, well, what type of device is it? Because the instructions work differently on a Mac versus a Windows versus a Linux, you know. So the linker has to go through and say, how do I make this able to open and run on your device, right? How do I open this locally? Um, the plain text that can be typed on a computer is the ASCII value. And I don't think I've talked about ASCII values yet, but, and actually, I don't know why that's in this homework because we won't talk about binary numbers and ASCII numbers until Friday. Oh, I guess that's fair. Okay, this homework isn't due till the weekend, so that's fair. Um, we will talk about the ASCII chart more on Friday. But what that says is, okay, we understand that there's a translator, right? I wrote hello world. The computer understands zeros and ones. How does the compiler change that data? How can we take the letter H in hello and represent that using zeros and ones, right? That doesn't make sense. H is a letter, not a number. So even if I can take a number and convert it to binary, I have to be able to convert letters and symbols, right? I'm going to have quotation marks. I'm going to have plus signs. How do I take a plus sign and represent that as a number? So what we have is a chart. We have a table, and I think I've got it in that week 1 folder potentially, but every character so every like plain text character that you can type on a computer has some binary number associated with it. So like a capital A is the number 65. A lowercase a is the number 97. Either a zero, I think a zero is 48 or a blank space is 48 and one of them's 32. I don't know. But a character has a binary number. So if you type in like a capital H for hello, the computer that goes through and translates that looks to see what is the number associated with that capital H. Oh, I mean, I don't know what it is offhand. Let's say it's 71. And so it says, okay, I'm going to take 71. I'll convert, I'll write that in binary. That's the way I send it to the computer. And on Friday, we will see how that process happens. How do you change like a decimal number to a binary number? So then we can fully kind of understand that whole cycle of taking a plain text character, converting it to a binary number. The binary number is what the computer understands. So the instructions that are actually ready to run is the executable. So we have already, done those pre-processor directives. We have already brought in the libraries that we need. We know what architecture we're running for. We have this completely ready to actually open up and use. Remember that your operating system is who controls the operations of a computer. Hey, that kind of makes sense, right? So your operating system decides who gets resources, who gets runtime, it controls your battery life. Like it can answer all of the questions about, your system status and all of that. Whereas an application software is one specific, like it's just one program on your computer that can just do one specific task. So like Microsoft Word or Adobe Photoshop or, some specific game that you've downloaded, Sims 4, right? It's just one application that does one specific task. Your operating system, like everybody has an operating system. Your computer doesn't open and work without one, right? So that's kind of universal. We all have operating systems on our devices, but we do not all have the same application software that's specific to your device. It's specific to what you have downloaded and installed, right? And then our words with special meaning would be reserved words. So those are new terms. So if you're not sure about them, you can, look them up in the slides or Google them or whatever. Just be sure that on Friday, if I asked you specifically, like if I gave you the definition with a word bank, can you match the words with the terms? Okay. Very large class. The class is pretty full, so I can't really ask you to spread out a whole lot. So I will have two different versions of the quiz. And so I'll have like an A version and a B version, and I'll alternate those. So the person sitting next to you will have a different quiz than you do. Just, be aware of that. So I think about done. I would like to kind of just show a little bit more in Visual Studio really quickly. So I'm going to just from scratch, I'm going to open. So I just went to Visual Studio. I open over here on the right-hand side where it says Get Started. I'm going to create a new project and I'm going to choose an empty project. And I mean, you might go through and do like the desktop wizard if you wanted to. You might could go through and do like a console app that's going to have Hello World in there already. I am choosing an empty project, and it has little descriptions here of what that means, right? An empty project says we are starting from scratch and there are no starting files. So I'm kind of doing this to give us a little bit of practice writing out that template. How do you add new files? We're just starting from nothing and building this up to kind of learn the basics here. Later, once you kind of know it, if you want to use one of these other ones that gives you, well, don't do that one. You don't want a graphical user interface right now. You could use the wizard, or you could use like one that already has Hello World for you. That's okay. Right now, I'm going to choose empty project. It does not matter what you name it. Name it something that you know. I do want to check this to have the solution and the project in the same directory. Visual Studio opens. I do not currently have any files. I can tell that I don't have any files because over here in this Solution Explorer panel on the right-hand side, where it says source files, there's nothing there, right? Like I have the folder, but see how it's empty? If I click on it or whatever, like there's nothing under there. I can't see anything. So this is just an empty project. So different ways to add a C++ file. One way is to come up here to these tabs up at the very top. See my mouse up here at the very top. So I can go to Project, Add New Item. That's one way. You can also come over here to the project where it says project, and you can right click and you can go to add new item. They both do the same thing. They both go to the same place. It doesn't matter which way you choose to add files to your project. Okay. So here, if you don't see that you have C++ installed, then potentially, like if you downloaded this on your own device, then potentially when you installed it and it had all those options for things that you might want to also add in with your project, you want to make sure that you include that C++, Windows development or whatever, so that you will also have the ability to write C++ code, because Visual Studio is not used only for C++. So just downloading Visual Studio doesn't already have everything set up for the language that we want to work in, because you might be using Visual Studio to work in, there are dozens of different languages that work well with it. So we have to tell it, yes, we are using Visual Studio, and also I need you to download the instructions and all of the libraries to be able to write C++ code. Okay, so I want to choose that. It's going to be here. I have a .cpp file where the .cpp extension stands for C++. Again, I don't care what you name it whatever you want. So I'm going to add it. And now I see that I do have a file here, and I've got it up here where I can write, where I have like a workspace. So this is no longer an empty project. Now I have a file. Okay. And I'm just going to add my basic little skeleton. So I have include, right? Here's that little preprocessor directive. I want you to include all of the instructions for IO stream. Go grab the library that allows me to do input output. I'm going to use the standard namespace. I'm just using everything in the basic standard template library right now. And then I need a main method. And now after today's lesson, we kind of know what that word int means too. That int is going to stand for integer. It's a whole number. You might have noticed when I was going through the slides and they had that sample code that there was a line in there that said return 0. Once upon a time, we had to have this command. This was our exit command. And so this told the computer, I am through with this program. You can stop now. The word return is like you can finish and then return this answer back out. And so return 0 was our command that said, like, we're done. What type of information is the number 0? That is a whole number, right? So that is an int. So the reason we have this int up here, we don't need it anymore. It's kind of outdated because now we no longer have to write return 0. Computer science updates all the time. And so we don't even have to write return 0 anymore, because now the language, through all these iterations over time, now it just kind of can exit the function implicitly based on just I hit the closing curly brace so I understand that I'm finished and I can leave. And we don't have to have that command anymore. But because it used to be there, I would return a 0 to show that I was finished. We tell the computer, when you receive this integer back out, that's how you know that you're done. So, okay, so at this point, hopefully we understand everything that is in our template. Okay, we know what int means. We understand that main tells the computer to start here. We know that we need curly braces around all parts of our program. This is where we're going to actually put our code inside of the curly braces. I guess you maybe don't understand the parentheses yet. You won't until much later in the semester. Just for now, trust me that you need them. Okay, that's good. That's where we can put input in. We don't need any input for main, so just they're empty for now. All right. And we understand our one single command, hello class. And, we've seen this a few times. I'm going to print out to the console. My text goes inside the quotation marks, and my little arrows are pointing this way because I'm taking the information over here, right? I'm taking my text and I'm sending it out to the console. What I'd like to do to kind of finish up this introduction is show you how we can get information the other way. So far, the only command we've really seen is cout. I want you to take something and print it out to the console. And let me just show that working really quickly. I'm going to hit the F5 command at the very top of my keyboard to compile this code and run it and see how it says, hello class. I get the output that I expected. And I can't quite reach the, come here, please. I don't know if you can see them, but the little Docker for recording is in my way here, is why I kind of had a hard time grabbing that. So, okay. Told us hello class. And then also, do you see here exited with code 0? So that implicit return 0 was down there at the end of the program. So the computer did, kind of everything ran correctly. You didn't get any errors. You made it all the way through, and we had our expected exit condition. So cool. We can do one thing. It works fine. I'm happy. What I would like to do to kind of finish up this week is show you the cn command, right? So all this does is print out to the console, but I would also like to be able to get information in from the console. I would like the user to be able to type in data and type in information, and my computer be able to work interactively with it and understand it. So instead of saying cout, I will say cn. That's fairly easy. And this time my flow of information is going the other way. So I'm going to switch the arrows. And what I tell the computer is if you're going to read in information from the user, that is data. And so we need some place to store the data. So we're going to just create a little variable here. We're going to just make a little place that says, you're going to get some information and you can put that information here. And I will explain all of this better next week. I'm running out of time to explain it now since I went through the homework and stuff. So this will make a little more sense to you next week. But here I have created a variable, right? This is the data type. String is just some text. This is the variable name. I was wildly creative and called it name. And then here's our command. Read in from the console, send the data here. So whatever the user types in is going to get saved inside of that variable. Now, instead of saying hello world or hello class or whatever, I can say hello to you. I can say hello to you specifically, right? So if we take a look at this, what have I done? Create a place to store information. Read in the user's information. And right now, the user doesn't know that they're supposed to enter their name. So this is actually kind of a bad, little program here. So let me just add that in there because they don't know that they're supposed to type in their name, right? So I'll say, enter your name. We'll give them some instructions. Enter your name. And then we will read in whatever they type, and we will store it inside of name. So whenever I print out and I say hello, whatever they entered in for name, it's going to be more interactive it will say hello specifically to the user, right? So now when I hit F5 and run this, I'm going to kind of move it over to the side here a little bit. See how it printed out enter your name? So here it says enter your name, and the cursor is flashing because it's sitting there waiting for my input. It's sitting there waiting for me to say, Micah. Hello, Micah. Hey. Prints out hello, and it prints out whatever we entered for that variable space. I believe I'm out of time, so I'll stop there. But here, so I'll stop sharing and okay. We'll talk about more about that next week, and I'll kind of go through and show you, how we can get in more than one name at a time, or some different things with that. But we have finished vocabulary. We have the basics of Visual Studio working. On Friday, we will take our first quiz over homework. So please go our first quiz over vocabulary. So please go through and do that homework, and we will talk about number-based conversions. How do you convert numbers to binary? I'll see you then. Stay warm, stay safe. Have a good day.